Hello everyone, welcome back. Now, just so you know, this problem doesn't exist like this in your textbook. In the textbook, it was water, but I was feeling weird and I just decided to be silly. So I changed it to nacho cheese. So nacho cheese is being pumped into a pole whose cross-section is 6 meters times 9 meters. Okay, that's an area. I like it. While cheese is discharged through a 7 centimeter diameter orifice at a constant average velocity of 4 meters per second. Okay, we got a velocity here. We've got another area from this guy because we can turn diameter into area. And it says if the cheese level in the pool rises at a rate of 2.6 centimeters per minute, okay, that's going to be, let's see, 2.6 centimeters per minute. That's more or less a velocity. Determine the rate at which cheese is supplied to the pool in meters cubed per second. So I'm trying to get a volume flow rate right here. V dot. Okay, now knowing all that, let's begin this absolutely insane problem. So first off, let's draw the insanity. Now, what I have right here is I have cheese coming out right here. That's coming out at 4 meters per second. I have an area, which is going to be equal to pi over 4 times 0.07 squared. I have stuff coming in at that volume flow rate I'm going to try to find. That is not supposed to be a gamma. That's supposed to be a V. I'm doing my best, everybody. And I'm going to have cheese rising in here. And the area of that's taken from this. And the velocity is taken from here. So its velocity is going to be 2.6 centimeters per minute. And its area is going to be equal to 6 times 9. So that's the problem I have here. All that detail. Now, we're assuming that, nacho cheese is incompressible. Is it actually incompressible? I've got no idea. I just changed it to be silly. By the way, let's keep moving forward. So now what we're going to do is we're going to write out the conservation of mass. So here it is. The amount of cheese in my pool, mass in my pool as a function of time, is going to be equal to the mass flowing in minus the mass flowing out. Now if we're saying nacho cheese is incompressible, because why not? As a note, most fluids are considered incompressible. There are certain situations where they can compress, but you've got massive pressures then, and that's outside of the realm of this course. So if I know that I have an incompressible, then I can just simply put it in terms of volume flow rates. As a note, I have a conservation of mass. There is no such thing as conservation of volume. That's not a thing. Don't call this conservation of volume. Okay, that's coming from the conservation of mass. We're just applying it in a particular way. Now, if I want to figure out how much is coming in, I need to first figure out what the volume flow rate out is. And I've got an area and a velocity. I need to find what the volume flow rate, the control volume, how it's increasing there. And I've got an area and a velocity. So with this, I should be able to solve this pretty easily. So let's calculate my volume flow rate out, as well as the change in volume in the pool itself. So we can do that. So my volume flow rate out is going to be equal to my area out, which, like I said, is going to come from the diameter given, times the velocity. So it comes out to be 0.01539 meters cubed per second. And then if I want to figure out how much the volume inside my control volume, which is right here, is changing, well, I need to know what the area of the pool is, which I have pretty easily, 6 times 9, and the velocity. Now notice here I changed centimeters to meters, and it was per minute. So I went ahead and converted it to 60 seconds. I could have written that out separately, but I wanted to make it a little bit more condensed. Now we have enough right here to solve the problem. We have our volume flow rate out. We have our volume in the pool. If we move this guy to the other side, we can see how we're going to solve it. So let's do that. So I'm going to calculate the volume flow rate in. I rearrange this guy. Just a little bit of algebra. And then I add together what I have. And so from that, I get my volume flow rate in is equal to my volume flow rate out plus the volume, change of volume in the pool versus time. And I get 0.0388 meters cubed per second. And that is my answer. There we go. Now I promise you the next example we do won't be nearly as cheesy as this one. But I couldn't help myself. So have an absolutely wonderful day, and I'll see you all in another video. Bye-bye.